carry on with question 21. So down here is a simple cooling curve. So what happened is that your room temperature is at 20 and you are given the boiling point 80. So you know that at the 80 degrees Celsius temperature, you should have a flat line like this. And at the room temperature, because it is already at thermal equilibrium, you will also have a flat line. So looking at the four options, I think it is quite obvious that option A is your answer. Okay, following we have question 22. The thing is that when a liquid is boiling, its potential energy is increasing. Okay, so therefore option B is your correct answer. Okay, the molecule itself will not expand, so that's why A is wrong. It also will not gain kinetic energy, because once it gains kinetic energy, it is indication that the temperature would rise, but during boiling the temperature actually stays constant. Then the last option here, breaking down into hydrogen and oxygen atom, this is a chemical reaction because the H2O molecules undergoes a reaction, okay, most likely electrolysis. Okay, then for question 23, the rate of evaporation basically is controlled by a various factor: your temperature, atmospheric pressure, humidity, and your surface area. So all four factors are valid factor, but you need to be careful whether how they increase or decrease would have an effect on the rate of evaporation. So when the temperature increases, the rate of evaporation would actually increases. So therefore this is wrong. Okay, let us skip to C first, since we want to go through all the options. So when you have a lot of humidity in the surrounding, what happens is that the water molecules will actually have a harder time to escape to the surrounding. Okay, so therefore when the humidity decrease, actually the rate of evaporation would actually increase. Okay, then for D, when the surface area increases, the rate of evaporation would increase as well. Okay, so the only option that will give you a lower rate of evaporation is actually when the pressure increase. So when the pressure increase, it will be harder for the water molecule to gain enough energy from the surrounding and then escape the water body. So therefore the speed of evaporation will be slower. So therefore your answer B. Okay, for your question 24, they ask you to find the speed and they give you two different graphs. So you need to be able to identify that the top graph, the x-axis is time, while the lower graph, the x-axis is actually distance. So when you have a displacement time graph, you actually could find out the period. So how do you read this is that one wavelength, when you have one complete oscillation here, this time axis will tell you what? This is one complete oscillation, right? From this point goes down, back up. So since period is defined as the time taken for one complete oscillation, okay, you can read the axis here. This is 10, so therefore this is 5. So one complete oscillation actually takes 5 seconds. So therefore your period is 5. And you know that your frequency is 1 over period, and you can get your frequency like this. Okay, then for the other graph, the displacement distance graph, this is how much one oscillation would cover, okay, in terms of the horizontal distance. This is one complete oscillation, right, from up, down, and back to the original spot. So right here will be one complete oscillation, the distance traveled after one full oscillation. So therefore this will give you the lambda, this will give you the period. So with this information, you can then put it into your V equals to F lambda formula. You will be able to find the speed. Okay, question 25. Question 25, first you need to recognize that the wave on a string is a transverse wave. Now, although they tell you the wave direction, you don't really know whether P is going up or Q is going down or whatsoever, but you know that the peak here represents a change of direction. Because it goes up, you have to change direction and then it goes down. So whenever you have a change of direction, your velocity has to be equal to 0. I will give you an example to why is this so. For example, if you are going forward and you start off with a velocity of 10. Okay, so if you want to make a U-turn, first this positive 10 this positive 10 velocity has to positive 10, positive 9, okay, I use finger like that. Positive 10, positive 9, and then slowly decrease to positive 1, then finally 0, and it can go into the negative direction. So whenever you have a change of direction, basically you must have a point whereby V must be equals to 0. So therefore, if you look at R, look at our options, to the right, upward, upward, at rest. There's only one option that is giving you V equals to 0. So without really looking into how P and Q move, you know the answer is D. Okay, then it is question 26.